Welcome to the notes on surface area of pyramids and cones. So again, our goal is to find the surface area of a pyramid and a cone. So let's start with the surface area of a pyramid. Okay, to find a surface area, just like any shape, we're just going to add up all that. We're going to find the area of each side and add them all together. That's it. Okay, so when you look at a pyramid, all right, we're going to have triangles and we got a base, which is in the shape of a square. We're just going to have to find all those and add them together. So regular pyramid, remember that means all equal sides and equal angles. So regular pyramid then is going to have a square base. So that's going to help us in these problems here. So here's an example of a pyramid. Okay, we've got our base. You can see it, which is down here. It's a square. To find the area of the base is going to be pretty easy. That's just going to be base times height. But the key is the slant height. Because if we want to find the area of each side, all right, so I'm going to do this kind of triangle in black here. If I was to redraw this triangle, and I'm going to kind of pull it apart, if I was to redraw that, the slant height is the height of that triangle. That's what we need to know. We'll already know the base, the base down, which is down here, is the same as on there, which is the same as this picture. But that slant height is going to be the height for the side triangles. Okay, and that's what we're going to have to find, not the height of the triangle of the pyramid itself. We may use that height in the Pythagorean theorem to find the slant height, but the slant height is what we're going to need to know. So here we go. Example 1, find the surface area of the regular pyramids. First, let's just break this down. Okay, how many sides does the shape have? Well, if you look, there's 5 of them. All right, what shapes are there? Well, we've got 4 triangles and we've got 1 square. And I'm just going to draw the shape of a square, all right? 1 square. That's it, okay? So now to find the area of the base, okay, it's a 10 by 10, right? They're all 10, so area of the base is just going to be 10 times 10, which is going to equal 100. All right, now the area of the triangle. Well, let's take a look. Here's our triangle right here. They give us the slant height. All right, the slant height is 8. We know the base is 10, so the area, remember, is base times height. So 10 times 8, which again is our slant height, the height of the triangle. All right, then we're going to divide that by 2. So 10 times 8 is 80 divided by 2 equals 40. Well, to find the area of all the triangles, I'm then going to take that 40 and I'm going to multiply it by 4 because there are 4 of those triangles. So that's going to equal 160. And then to find the total surface area, I'm just going to take the area of the base plus the area of all the triangles. So total surface area then is just going to be 260. In this case, it would be centimeters squared. So that's how you're going to do these problems. Find the area of the base, add it to the area of all 4 triangles. Find the area of one triangle, multiply by 4. Let's take a look at an example that's a little bit more difficult. Okay, so this one, you can see our base. All right, it's a 6 by 6. So I'm just going to kind of write that over there. Base equals 6 times 6, which is going to give us 36. Now, our triangle. Okay, our triangle, let's say we're going to try to find this side right here. All right, we do not know the slant height right here. We do not know that slant height. So if I pull that, when I redraw that thing, we know the base, we know this is 6, but we need to find that slant height. Now, in order to do that, we're going to have to use this height of the pyramid. So when I highlight this height of the pyramid here, the height right here, if I draw a line over here, you can see that I've created a right triangle. And we can use Pythagorean theorem to find that height. Now, the key is right here, all right, that if this side is 6, then this piece right here is going to be half of that side length, so that is 3. So when I look at my right triangle, when I redraw this thing up here, we're going to have the 3, we're going to have the 4. Again, the 3 comes from half of 6, and then we're going to have to find our slant height is going to be our x. And I'll put that x in green so you guys can see. That's the piece that we're trying to find. Now, when I do Pythagorean theorem, I'll kind of do that below here so you guys can see it. It's just going to be 3 squared plus 4 squared equals x squared. Now, when you solve that, all right, that's going to be 9 plus 16 equals x squared. Well, we know that x is going to end up equaling 5. So that this x right here is 5. Now that I know that, I can find the area of that triangle. So the area of the triangle, okay, is going to be base time, so we'll do the triangle here. Area of that is going to be base, which is 6 times 5 divided by 2. All right, 6 times 5 divided by 2, that's going to give us 30 divided by 2 is 15. that equals 15. But now I'm going to take that and I'm going to multiply it by 4 since there are 4 triangles. So 4 times 15, that is going to equal 60. So my total surface area is going to equal the base plus 4 times 15. So we're just going to say 36 plus 60. So that's going to equal 96 square feet. So that again, how do you find surface area? You may have to do Pythagorean theorem. Okay, now a cone. A cone is a little different. A cone does have a formula, right? Because every cone has a circle for the base. Well, every circle you find the same way. So the formula for a cone is, you guys can write this down, right? It's going to be radius squared times pi, right? That's the area of a circle. Again, some people say pi squared. I like radius squared times pi. Then we're going to add, all right, plus the radius times L, which is the slant height right here, times pi. Now again, remember the slant height is this piece right here. Sometimes they'll give us the height and we're going to have to use Pythagorean theorem again to find it, but it's not the height of the triangle, it's the slant height. Let's take a quick look at a quick example. Here we go. So surface area, again, this is the formula for surface area of a cone. So surface area is going to equal, the radius is 4. We're going to square that times pi plus the radius, which is 4 again, times the slant height. That's our L. Okay, again, that's L, which is 6 times pi. So 4 squared is 16 pi plus 24 pi. So when you add that up, you're going to get 40 pi. So, and you can keep it right like that. 40 pi, you can do meters squared. You can do that as your answer, or if you want, you can make that into decimal, which will be approximately 125.7. So decimal's fine, or just keep it in terms of pi. Let's take a look at one more that's a little bit more difficult because we do have to do Pythagorean theorem here. So when I look at this, we don't have the slant height, but I've got a right triangle here, and I can find L using Pythagorean theorem. So let's do that first. All right, we've got to find the slant height. So we're going to say 5 squared plus 12 squared equals, all right, I'm just going to put the L there squared, the slant height squared. So that's 25 plus 144 equals L squared. We know it's going to be 169 equals L squared. Again, square root each side, square root. So our slant height is going to equal 13. So now that I know that equals 13, I can solve this problem. So here we go once again. Surface area equals the radius squared, which is 12 squared times pi, plus the radius times the slant height, now we know that, times pi. So when you figure this all out, you're going to get 144 pi plus 12 times 13 is 156 pi. You're going to add those together, and you're going to get 300 pi. And that's inches squared. Oops, forgot a 0 there. Let me erase that. 300 pi inches squared. If again, you want to make that a decimal, it'll come out to be about 942.48. So there you have surface area of pyramids and cones.